Okay, it's the first video in a while. I wanted to talk about question number, actually it's question number 1 in test number 3. So it is calculator active, and I just wanted to, not that I thought this problem was particularly hard, but I just wanted to show you a shortcut you might want to use in the future, and also to maybe talk a little bit about how to justify your answers so you can make sure you get maximum points. So the first part, they give you this equation and give you the domain from 0 to 3 on the closed interval there, and they just want you to find the x-intercepts of the graph. And so that's just, do you know how to use the calculator portion, and just listing just the x-intercepts. And then they want us to find on part B, find the intervals on which the function is increasing. So that's the part I wanted to show you. And so let's go ahead and put it in the calculator, which I already have it stored in there. And I just played around with the window so that I could get a better view of it. You can pause the video if you want to set up your calculator to match this, but when I graphed it, I see that it has those 0 points you can see listed. Looks like 3 of them, of course, at the origin, and then it passes through here a couple of times. So, you might want to zoom in a little bit to find these 0 points. And so let's just find one of them. Let's go to second calc and look for the 0 and try to hone in on this one right here. This one's a little bit tricky, I'm thinking, because it sort of changes. Let's see if I can find that one. So I'm just looking over here at my y value, and whenever I get to negative 0.04, oops, I messed up, didn't I? Let's try that again. So I'm trying to find the 0, and so I need to back it up just a little bit above the x-axis. So just when the y gets positive, right about there. And since it's so tight, I'm just going to get to the negative 0.02. Looks to be fine. And there you can see the 0 is at 0.964. So you want to make sure that you carry that out to 3 decimal places for the other two. Obviously not 0, but anyways, let's take a look at B. So the part B, which we could easily do with by taking the derivative, which we'll take real quick just in case. So the derivative f of x is equal to the ln of x plus 1. It's just 1 over x plus 1, and of course, since the portion inside the ln is just x plus 1, the derivative of that is 1, so we don't have to worry about that. And this second portion minus the sine squared of x, of course, is minus 2 times the sine of x to the first power times a negative cosine. Cleaning all that up, you would get what? 1 over x plus 1. You get a positive. Negative times the negative gives us a positive sine of x and cosine of x. And that pretty much would give us the derivative. Let's see. So now what we need to do is stick this in the calculator. It looks like perhaps they made a... Whoops. I sure did make a mistake, didn't I? Sorry about that. This derivative right here, first part's okay. The derivative of sine is a positive cosine of x, so be careful right there. Don't make that same mistake. So in fact, it is a minus 2 sine of x. Anyways, obviously, if they ask you to find the derivative and you need to actually list it, that's the way you do it. But since this is calculator active, I'm going to show you a little trick to put in the derivative in there without having to actually calculate it, if it's allowed. anyway, on part B, they want to know when is the function increasing? When is f of x increasing? Well, it increases when the derivative is greater than 0. So all we have to do is, if we can get the graph of the derivative on there, just to see where it's above the x-axis. Above the x-axis. So let me just show you this shortcut. So in your graphing portion, you're going to go down to the next line here, and we're going to put the derivative in here. I like to use this shortcut right here, which is number 3, alpha f2, and then select number 3, and of course we're dy over dx, and we're going to take that function that's in y1 of your graphing. So I'll go to alpha f4, just another shortcut, and I'll put y1 in there, and this x equals, instead of doing it at a point, we want to do it for all x's, so just put x equals x right there. And then I'll go ahead and, so I don't get confused with the graph, I'm going to go ahead and turn the first graph off, which we've already seen. Try to do that. There we are. And so there we are. And you can see that it's positive there till it reaches that point somewhere between 0 and 1. It's positive again all the way out till, looks like past 3. So looks like we're going to have 2 intervals where it's greater than 0, which means that the function is increasing there. So of course you would just use the 0 function, since this is the derivative right here. So second calc, let's just find this first 0 point. Bear with me. So let me get on the upper side of this root or 0 point and get below it, but not past the minimum right there. And there we are. We have it's increasing, so f of x is increasing till 0.398. So the justification here is on the interval from 0 to 0.398, we're increasing. So you can write it in this sort of notation if you like. And also it's increasing on the second interval, which we need to calculate that 0, but if you do it, you'll get 1.351, looks like. And it goes all the way until you get to 3 here. So it's the rest of the graph. So I can do that. And also on the interval 1.351 until you get to 3. And that's an open interval, not including the endpoints. And it's increasing there, and you can say that it's because the derivative is greater than 0. It's increasing on those intervals. Alright. I'd probably move, actually I'd probably write it like this. F of x is increasing on this interval. Having troubles. It's increasing on the intervals and list them there, and you can just make a statement down here because f prime of x is greater than 0, and that's great justification. Alright, let's take a look at C. It's getting kind of long here. Find the absolute max and the absolute minimum value of f. So of course if we go back to our calculator, this is the derivative, right? So now that we have our points, I suppose we could sketch a little number line here that it might help us out a little bit, but so we'll do that, I guess. So this is the derivative, we have our 0 points and our endpoints. 0 and 3, we're not going to go past those. And it looks like we had our first 0 at 0.9. I'll just put a 0.9 there. And then we had another one at 1. Well, that's the original 0. I'm sorry. We had 0.398. 0.398. Alright. So we have one at 0.398. And then we had another one at 1.351. Okay. Anyways, this is the derivative. And we can go back and look at our calculator and see that it's positive here, negative here, and then positive the remaining portion of the graph. So we're looking for, we have to test, we actually show them the test for the minimum. The minimum occurs where? Let's draw our arrows here. So we're increasing in this area, starting to decrease in the middle portion, so that's a relative max, which we need to check when we check an absolute max. And it looks like we have a relative minimum right here. So that'll be what we check. And of course the justification the reason it's a relative max is because the derivative, this is our relative max. Our relative max because the derivative changes from f prime of x changes from positive to negative. At x equals 0.398. So that's good justification as to why we're going to use that as a test. And for the relative minimum, when we're going to use the test for the absolute minimum, we're going to have to test the relative minimum, which occurs at 1.351, and we'll use the same justification. F prime of x changes from, in this case it would be from negative to positive at x equals 1.351. Alright, so, and then of course we're going to test our endpoints. So maybe I would make a suggestion is to just go back to your calculator, and we don't need that derivative graph anymore. Turn this one back on, and I'm going to turn the derivative off, and I'm just going to list out my values. So I go to my table, and I'm going to change the setting to the table set to ask, so that I can just type in the values for the independent variable, which of course is x, and you just type in let's test it out at 0. That is certainly an endpoint, so 0 is 0, and then our next test point is going to be 0.398, and we'll record that number, and also at 1.351, and we get that negative 0.976, 0.0976, so we would write down 0.098, and then of course test our last point, which is 1.3664. So now that you have all that information listed, the function's absolute minimum value would be that negative 0.098, and that occurs at f of 1.351, and we have a absolute max value of 1.366, and that occurs when x equals 3. So it's a fairly straightforward problem, and hopefully you've seen that. You know, a couple of pitfalls to make is when you're putting in your function, your original one, if it's sine squared of x, you probably want to set it up like this. And hopefully this shortcut was helpful for you, but if not, you could calculate the derivative. That might be a good way to check to make sure that you're doing it correctly, is to put it in the calculator like this. And anyway, good luck with the rest of this.